Can you guys hear me okay? Cool. Thank you. So before we start, I really want to mention that um, what logistics wise, hopefully you guys are on top with everything. So where are we standing at this point? I want to say that we have homework one due by end of this week. So I assume that you already pulled from the GitHub repository and you are able to see what the problem is about. And then data camp, we finally got the data camp. So it's good that it's free for you, that you would be able to review the contents there. So I also put a deadline on the data camp review sessions. That would be the end of next week, which would be 23rd. So by now, actually, I checked all of you have accepted the invitation on data camp. So which means that you already have access there, and you should continue to review those. Um, only homework one is due by the end of this week. Homework two, we haven't talked about it yet. And then I want you to spend more time on the data camp because I know that only a couple of you guys finished, um, a handful of you guys finished data camp. The rest of you haven't started or halfway through, but you should finish them by the end of next week so that we kind of on the same page on using Python and using some of this machine learning tool set. Okay. And any questions? Feel free to type or feel free to um, talk. Yeah. And I hope you can finish. No, the link is actually still there. I actually, it's going to be a couple months until the end of the semester, but I actually hope you can finish before end of next week because otherwise, which would be 23rd, right? I think. Yeah, 23rd. Yeah. It's right up. Yeah. Yeah. Okay. Any other questions? Yeah. Right. Um, I think what I actually don't know exactly, but let me check. Anyone have suggestions? I couldn't. I don't have that at the moment with me. Let's see. Which Docker image you are talking about? Yeah. No, I don't think you need to. No, that's fine. Yeah, 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 yeah. I think I think you should install them. You should install them. Yeah. Okay. And then again, even though here I said homework one would be what I'm saying, homework one is due by the end of this week. What I'm really talking about is these questions. You should get it done by the end of this week. But for these ones, I'm monitoring on the data camp. You should finish them by the end of next week because this would be something that we would be using down the road. We cannot wait until later in the semester anymore. So hopefully, of course, if you feel like it's too much, you wouldn't be able to finish. Which you should be able to finish because I know some of you already finished. So if you have difficulty there, let me know, and then we can figure out something else out. So that's what I'm saying here. Okay. And also want to make sure that of course, you install Docker, and then because purely just because in the future we would be using some of this as well, and then I will provide the feedback directly on your GitHub homework repo, but the grid is actually showing up on the Blackboard system because Blackboard is used for the grading and everything, put them together. And just want to let you know that late homework will be penalized. Of course, feedback will be delayed as well. So today, what we are trying to cover is something called data pipelining and processing. So if we, yep, yep, right. No, that's why what I'm saying is in GitHub, you just I would see the GitHub repo and then I would be able to see it. So as long as you put them into the GitHub repo, I would be able to see it. But I just put the homework grid in the Blackboard system. Yeah. Okay. Yep. Right. Uh, it's actually invited through your email. Yeah, if you check your email, there's a link, and then you can click that link so that you can join. If you have issues, you can always talk to me in Slack so that I would be able to help. You can say, okay, this is my email. It doesn't appear that I got this link. Can you invite me again using this email? Things in that nature, then I could invite you again. Okay, no problem. Okay. So now let's go through this section. What we're trying to cover is really the data pipelining and data processing. So I want to you to realize that what we're trying to cover here. See, majority of the time, what we do is we have key three steps. The first step is ingest raw data. Second step is manipulate data into a desired shape. And then third step is perform analysis and distribute to stakeholders. So if you think about how to get the raw data in, it would be something like in R you can use read CSV. You could do similar things in pandas as well, in Python. And then next step, what you do, manipulate data into some sort of relationship. So you can convert some of the variables, make sure that the numerical ones would be really numeric, and the text ones are going to be string or text. And then on top of that, you perform analysis. So at this stage, it looks simple, but we want to look at what if things are changing. What if different pieces? How can we put all of this together? So for different requirements as well. So a simple example here. For example, we import locally stored CSV file, and then we do some sort of aggregation and imputation on the locally installed software. And then we do some sort of summary analysis, could be modeling or visualization on your locally installed software, and share via PowerPoint. So it can be as simple as you can get some media, and some summary statistics for the data. So that's a simple example. And then what if the data is more than a single file? Then the question becomes, can we use tools to pass the data into tabular form, and can we design a data model such as choosing a local database client and perform ETL. ETL is extraction, transformation, and loading. So this is database language. So in other words, are we able to parse multiple files and put them into the database? Could be relational database, could be anything. Even in a Hadoop file system, it would be a flat file, and then you put them together and design data model, and try to think about to do next. Right? When we manipulate data in a second stage, we could do some sort of query and join the data into data frame, and then we can some sort of data frame objects that fit for analysis. So you could do some sort of SQL join, for example. You can do aggregation here as well. And then in terms of analysis, now it could be a little bit fancy. You do more modeling and aggregation. So now, what if the new data is periodically available, meaning that the database needs to be, instead of local, it could be on a network, and then your jobs needs to be written to ingest data every time it comes in. So you write some sort of cron job to help you to periodically to update the data. And then once that happens, you have to think about start building data lakes and data marts so that the data is always ready for analysis. And then at this point of time, you could, instead of generating static reports, you could consider online dashboards and deploying models. So that would be this whole pipeline. So for data engineering, if we talk about data scientists, it really have two aspects. One of them is data engineering. The other one would be analytics. And then majority of data engineering work is really done in the first two components, and the analytics side would be the third one. Of course, for the online dashboards scenario, and the model deployment could also have certain as elements of the data engineering as well. So when you think about going out for work, it could be which elements that you want to pay more attention. Is data engineering, or is data science, or data analytics aspect? Even though in the real world we call them data scientists, but in reality, one way or the other, you should have some sort of focus. If you're coming from computer science or any of the computer programming background, you probably focus more on the first two components. And then if you are more statistician background, you probably focus more on the third components. What if every step becomes so large? What if every step becomes so large to handle on a single machine? Then we start thinking about moving the database to a network and setting up infrastructure for multi-user access. This is really the cloud, right? So, and then or the even the internal Hadoop system, which essentially a cloud. And then when you have done that, then you can spin up clusters to utilize multiple machines, and then you could optimize the best way to do every aggregation, because efficiency becomes important consideration here. And then in terms of analysis, we can spin up clusters to utilize multiple machines and need to put in unit tests and make sure that things fail gracefully instead of once something fails, the whole system crashes. So this is something that you should pay attention. So at this stage, we haven't talked about anything about um, the architecture of big data quite yet, but sooner or later we will discuss things such as Hadoop architecture. What is a master node? What is a slave nodes? And then what's the responsibility of master node and slave node? And then we would talk about the MapReduce framework, and then you would understand what is a mapper, what is a reducer, and then you would have a better understanding of how we can utilize that multiple machine, and how can we use the reducer function um, uh, reducer function reducer function to aggregate the results from the each individual slave nodes. So Havik, you have a question here. You said if this is in a cluster, what do you mean? It would be clusters, multiple machines. Yeah, yeah. It would be master versus slave nodes. Usually, we are talking about multiple machines. It's a machine cluster of machines, and then each individual, each machine has its own use or purposes. Okay, and then it becomes more, could be more requirement on the data itself. What if the stakeholder wants real-time data access, and you really want to save money? And then you still the same thing. You inject real raw data. That means that you use real-time streaming processing. You use cloud computing services to inject raw data. And then when you manipulate data into a desired shape, you would do real-time streaming processing using cloud computing services. And then even you do analysis, you use real-time model hosting using cloud computing services. So at this stage, then it really what really we are talking about is we can leverage a lot of the cloud computing. Yeah, and then we can take a look at this. I want to make sure that I have. Hold on, I'm trying to get access to those two. Give me 1 second. Okay, here. So there are more detailed information in two of the links. We want to quickly go through some of this so that you could get a good understanding. Because at this stage, if you ever heard, we talk about Spark and Scala is really the uh, which is really on the cloud. You can real time to look at some of the information. Actually, I would like to introduce you to some of the big data architecture maybe next time, and then you would have a, a better understanding there. So let's look at one of these links. So in this one, it says the data link. It's a data lake company. So what they do is they do uh, all sort of data related stuff, such as all of this data related work. And then they do all of this. So they can store all types of data. They can create, refine, standardized, and trusted data set for various use cases. And then they could store data for longer periods of time to enable historical analysis. You could query and access that data, and then you could manage streaming and batch data in a converged platform, and provide shorter term time to insight with proper data management and governance as well. So that's what their information. So if you look at this data architecture, traditionally what we do is we use data sources, and then we use ETL, and then we use data warehouse, and then we do data discovery, analytics, and BI, and then in terms of data links, what we do, what in the new architecture, what that would be, it would be not all kinds of data, including streaming, unstructured data, and various sources. I'm sure that you know the difference between all of this. So that's really the the um, the outbreak of the big data explosion, which is coming from all the streaming data, all the unstructured data as well. And then they use this data lake to do some sort of transformation, and then they have discovery sandbox so that we would be able to access that data based on uh, their some sort of cloud computing services, so that we can better come up with data discovery and data science analytics from out of the data lake. That's the architecture. Yeah, they build different things, but in general, that's the whole purpose. So this is just give you a idea on what current architecture could look like based on what we just said in terms of data pipelining and data processing. Again, you could go through some of this yourself as well, but this is really to give you an idea on what can be done in terms of data pipeline. Separated into different zones that they call. So enable the data lake. So it says ability to ingest vast amount of data, ability to handle a wide variety of formats, different data sources, different formats, and then build in repeatability through automation to pick up incoming data and apply predefined processing. And then on top of that, we could have meta management, metadata management. Metadata capture and manage the operational, technical, and business metadata, and provide some sort of visibility and reliability to in the lake, and reduce time of insights for analytics that they are able to provide, and then different also different data linkage and enable audit and traceability. So that's this. And then for different component that they have, there are more discussion on each of this. On top of that, data security and even the life cycle of data management are also considered. Engage the business data catalog and self-service data preparation. So that's really the whole spectrum of coming from raw data and then provide the service on some sort of data analytics and discovery ready services. This is giving you a high level on why data lakes is important and how that is done here in this company. Some of the key consideration. And then one of the key application. Again, that's the end. But this is really, if you look at this one, whole spectrum of the data lake. And then if we look at the second link, and the big data architectural patterns and best practices on AWS. What technology you should use and what's the key challenges. We know this already. I hope you already know volume, velocity, and variety. That's really three V's that we talk about in the big data. And then we already talked about some of the needs that we earlier from the slide set. It's can be batch processing, can be stream processing, and then on top of that, we could have machine learning to help to understand the data itself. And then of course, cloud also goes from virtual machines, managed services. Even now, you don't need a server, just use the cloud directly. And then a lot of tools that's in the space, including a lot of this. For example, EMR and S3 would be something that was in Amazon, and then also some other some things coming from Amazon as well, and RStudio and Spark, even Pig, Hive, Hadoop, all coming from the MapReduce framework. Okay. Let's look at this, and we're trying to give you, the same kind of idea there. How to collect the data, and could be coming from anywhere, a lot of places, and then you want to look at, how good is, basically you want to see how good the data is. In terms of the, volume, in terms of the atom size, latency, how quickly we get it, and then durability, as well as the request rate, so that you know what is the hard data, what is really the cold data. Of course, I think here we should also pay attention to the quality of the data itself, instead of all of this, just all of this as well. In terms of storage, it could be in memory, it could be in database, could be in file system, could be in queues, could be a lot of this as well. This is coming from Amazon, so they do explain to you what does Amazon provide of this, how does those help. And stream storage, how about messaging? In terms of you want to look at all of these different services that Amazon provide. File storage, and HDFS as well. Yeah, look at some of the applications. So yeah, just long story short, you really want to review this again on your own and take a look at a lot of this, so that you know what's offering. And then not only Amazon, a lot of just as we know, Google is offering very similar services as well. So in case that you are interested in some of this, you should do a little bit more research here as well, and also look at specifically we want to look at how the service is provided. I mean, what type of analytics that we could do. So so data pipeline essentially, at least essentially involves two key components. One is the data collection, second is the data storage, and then that's more like data engineering part. And then on top of that would be analytics, would be coming from processing and analyzing. So these first two components is really data engineering part, and then the second and third component is data analytics part. Yeah, I don't know if I think it's actually, even if you test on their cloud, I don't think it's that expensive. So potentially you could try as well. I don't, on top of my head, I don't know if there's anything that can be leveraged for free, but I remember it's not too bad if it's small data. It doesn't cost a lot of money. Of course, when you test a lot of these services, it, you at the end you don't you don't you probably have multiple tries. Then it becomes harder. So it's not free. Okay. Yep. So this is really the gist that we want to cover today. We also for the next week, maybe I will send you a notes. Right after this, we would have something, some reading that you need to do after that. Um, so John just mentioned that Amazon does have some free usage for most of their services. I think if you could share with us through Slack, that would be helpful, so that some of you, if you want to test, that would be great. Okay. That's pretty much that I plan to cover today. So Kuma said we have this AWS EduKit. So it's something that worthwhile if you want to, I guess. Yeah, it's worthwhile to explore. I actually explore myself as well. Maybe we can leverage some of this and then try it out. Okay, thank you for sharing. Any questions? I think because we're kind of slow in terms of the overall progress, so we are still kind of focusing on first two things for now. So I think your focus is really should be on the data camp. Should finish those three courses by the end of next week. So if, as I said, if you haven't got the invitation, if you haven't joined the data camp, then you should send me an email or send me a private message on Slack so that I can add your email address into the data camp and you would be able to review them. I actually checked today. I thought every one of you are able to access, but just now earlier someone said he cannot. So let me know offline. Okay. I'll stop here and then again try to focus on the data camp, and then we would be able to go over a little bit more next week, 2 weeks from now. Okay. Thank you.